Hit like, subscribe, and join the journey to becoming a coding master. When we talk about interpretability in machine learning, we are talking about how easy it is for us to understand what a model is doing and why it is making certain decisions. Machine learning models, especially complex ones like deep neural networks, can be like black boxes. They take in data, process it in ways that are not always clear, and then give us an output. Interpretability is about opening up that box and giving us insight into how the model works so we can trust it and use it responsibly. Think of it like this. Imagine you have a friend who is really good at solving puzzles. They always get the right answer, but they never explain how they do it. It works, but you start to wonder, how do they know what they know? What if something goes wrong? The same applies to machine learning models. When we understand how the model is making its decisions, we can better identify problems, ensure it is working as expected, and even improve its performance. A common way to approach interpretability is by simplifying models. For example, decision trees are easy to interpret because they show clear, rule-based paths from inputs to outputs. If a model says the customer will buy the product, you can trace back through the tree to see which features like age, income, or previous purchases led to that conclusion. But sometimes we need more complex models, like deep neural networks, which are harder to explain. These models might give great results, but they can be tough to understand. One approach to improving interpretability with these models is using techniques that explain individual predictions, such as SHAP values or ALIGN. These methods try to explain which features were most important in making a specific decision. Let's take a look at a simple example with the decision tree model and see how we can interpret it. Load the iris dataset, a well-known dataset for classification tasks. Split the data into training and testing sets. Train a decision tree classifier. Predict on the test set. Output the accuracy of the model. Visualize the decision tree. Explanation of our code. 1. We use the iris dataset, which includes features like sepal length, sepal width, petal length, and petal width. 2. We split the data into training and testing sets so we can train the model and then evaluate its performance. 3. The model is a decision tree, which works by asking a series of questions. Example, is the petal length greater than 2 centimeters? To make a decision. 4. The tree is trained on the data and we use it to predict the species of flowers in the test set. 5. We calculate the accuracy of the model by comparing its predictions to the actual values. 6. The tree plot shows how the model makes decisions, with each split showing a question based on the features and the resulting class label. Now run our code. Before we dive back in, I want to hear from you. If you're loving these tutorials, drop a like and hit that subscribe button. It only takes a second, but it helps you stay connected with this community. And hey, don't forget to comment below with what you want to see next. Your feedback helps shape future content.